And the main question to you as a biologist and someone who is examining since 40 years social insects would now, is there something like a media, or what could be considered as a media in a very wide sense, which social insects like ants, bees, wasps or whatever are using, or would you say that they communicate without media?
I don't think any communication is possible without some kind of media, because there are signals, but the signals are to be interpreted in a context, and without the context the signal doesn't really make sense. So the same signal in two different contexts can mean something completely different. There is, in that sense, media which then integrates different things. So in the case of social insects, they use vision, they use acoustics, they use smell, and then there is a context, and all of this then has to be somehow integrated, and that is what I would sort of say the equivalent of the media would be.
Yeah. So the context could be considered as Umwelt if we deal with the
Yes.
terms of Jakob von Uexküll.
Yes, yes.
If you meet someone after a while and you hit him on his back, what is the media in this case?
It's the gesture of his hitting you on the back. It's the level of reception from you, which could even be uncomfortable, and the context. You take these together, and then only you make sense out of it. Mm-hmm. Therefore, it's not in his gesture, it's not in your reception, it's not just in the context, but there is some space in which all of these three are put together, and then you make sense out of it. Because I wouldn't call it a third body, I would call it a space. A space is created which was not there beforehand, and I personally experience this very often. The examples are, if I go into a modern art gallery and I do not try to interpret every item in the installation. I do not try to find an explanation which might be consistent with your explanation. But looking at this modern art transports me into some space where I can think much more concentratedly on what I want to think about. And I find that I'm liberated somehow from the reality, and I get new ideas, I think very clearly, I plan my life very clearly, and I'm very, very happy in that space. And then when I come out of the gallery, I'm sort of back to earth. This happens to me when I go to modern art galleries. It happens to me when I listen to Western classical music, which I don't really understand. But the nice thing is I don't understand. It is because I don't understand.
Which is not a rational thing, but something which is perceived by the whole consciousness.
Yes, because I think it just makes you forget some of the other things and allows you to see. I think the biggest problem with humans is not inability to remember, but it's inability to forget. Inability to remember can be corrected by various ways. I can write down your phone number on my book and look at it when I want. But it is inability to forget, which is, I think, the biggest problem in bringing out our creativity. Our creativity comes out when you're able to forget certain things. And that inability to forget is what keeps pinning us down to what is normal and what is routine. The thing that impressed me most was this emphasis on how you can switch off. So he has this example of the tick, which at different times in its life is extremely sensitive to one kind of sensory modality, and a little later makes no difference to that tick. And this is how animals work.
So they switch senses and they switch media,
right,
in a way.
Sometimes we don't think of this, but it's so obvious. If you're hungry, the same food tastes very good, and if you're not hungry, it doesn't taste as good. If you take an example of honeybees, for example, when honeybees are sitting on their nest, they are defending the nest. There is honey, there is brood there which they have to defend, and so they're very aggressive. So if you stick your finger into that, you will immediately get stung. The same honeybees, when they have to build a new home, they will leave this home and they will settle down on a tree somewhere temporarily. Again, you have hundreds of honeybees, but they have nothing to defend. And there, if you put a stick in your finger, nothing, they won't do anything. So obviously, there is some other space where all this information is being put together and calibrated, checked in some form until you make the final perception.
So it's a mixture of action and desire. And action obviously is very important to do something in order.
Right, and the internal state then decides, and this is true. Little microscopic amoebae which live in the soil, when they are hungry, they eat on bacteria in their surroundings. But when they finish all the bacteria, they become hungry, and now their behavior is completely changed. Now they start producing different chemicals. Now they come together and they become a social animal. When there's food, they are solitary. I don't need you. But when they're hungry, they actually come together. And they have very elaborate process mechanisms of attracting each other and coming together. And after coming together in some species, some of them actually die and produce a stalk on which the others sit, so that they can be blown away to some other place where there is probably some food. In the case of the wasps that I study, they are social, but they have not forgotten how to be solitary. So an individual is perfectly capable of living by itself. It builds its own nest, lays its eggs, waits for the eggs to hatch, then finds food and feeds the larvae and waits till they become adults and fly away. They're capable of doing that. But many of them live in a group where only one reproduces. And the question is, why don't everyone go off on their own? Because then they can have their own offspring. And what our research has shown is that a solitary individual has very little success. The probability of succeeding is very small. Whereas in a group, the probability of succeeding is very high. But the probability of succeeding is not the same for everybody. Some individuals are better at succeeding solitarily, and some are not so good at it. But even that depends on the environment. So you can think of everybody having a scale from 1 to 10 of succeeding in alone. So I have a score of 2, you have a score of 3. But that really depends on the environment. If the environment becomes bad, then my 2 becomes 1 and your 3 becomes 2. And whereas the group always succeeds much more. And if by changing the environment you can change the propensity of individuals to be social or to be solitary.
Do you think that this is triggered by instinct or by communication, or is it a mixture? If there is a change from one state to the other?
The ability to behave altruistically must be instinctive. But to switch on that program depends on the context, on the environment, on your internal state, on who is being likely to benefit from your altruism. All of those things will sort of come into the picture when it comes to the actual execution.
But there is something which is triggering it, or a sign which is sent.
Yes. That's why we find that animals make mistakes. So for example, people often report that animals sometimes take care of the young ones of some wrong species. And this is because when the animal is sensitive, so for example, when an animal has lost its offspring, it is very ready. And at that time, if a helpless offspring of another species comes in, just like humans, humans would adopt because they find. So similarly with animals, you may find that there is a mistaken identity and they would then care for some other species. So many people tell you, my cat and dog are very friendly with each other because you put them in an environment which they never experienced before, and you can actually show that they do the right thing but in the wrong context because you have created the wrong context. In fact, in much of animal behavior we find that animals have simple thumb rules to assess the world, and those thumb rules work until humans interfere with their environment. If we interfere with the environment and change the world, then of course the thumb rules don't work anymore. And in almost everything in animals there are these thumb rules, and we discover these thumb rules by actually placing the animals in an artificial environment and then seeing what kind of mistakes they make. And from the mistakes then we understand that this must be the kind of thumb rule that these animals use.
You described that once with wasps, and that one is touched by a certain thing, but out of a sudden, if there are two competitors of queens, the child is killing the mother.
Yes,
if she's not willing that is Shakespearean parallels.
Yes.
How would you describe projection of humans on the animal behavior?
It is almost inevitable. I think we would feel that way. But if we want to change our behavior, then animals are not a good guide, because in animals you can find everything. I think what especially with my own research on wasps, people always ask me, what can we learn from this? And the answer is, we cannot learn anything directly, but the animals hold a mirror to us, and we can look at ourselves in this mirror. So if you look at how these animals behave, it makes you understand yourself better. It allows you to reflect on yourself.
The wasps, for instance, are they able to learn? Yes.
Oh, yes.
Are they able to learn individually and socially?
Yes. Yes.
And how do they store their knowledge socially? What do you think? Wasps, for instance.
Mm-hmm. Well, one doesn't know for sure, but if I were to make a hypothesis, I would say that if you store information about something in the environment along with the context, then that allows you that becomes social memory. In modern information technology, we call it, we tag. We tag everything with something. So if you make a list of books that you have read, you then can tag those books. You can say this was interesting, this was about war, and this was about science, and this is meant for children. So you use tags. So all the things that you store, if you tag them appropriately, then you can get social memory. If you have multiple tags, and if you want to then interpret this along with all the tags, that is what I see as media, because it's not an individual item of signal, because somewhere all this has to be integrated. It's easy to see this in terms of examples with human beings, but I'm sure the same thing is true with animals. Suppose you are watching the theater, and on the stage somebody is killing somebody. You do not react in the same way as if you're on the street, somebody is killing somebody. So now you know that you are in the theater and this space is different, and so same kinds of interaction should be treated differently. I'm sure the same thing happens with animals. Young animals who have play fights, or even the mother cat would teach the kittens how to play, how to fight, but it will not injure that individual.
Do wasps imitate each other?
You only blow on one wasp and she raises her wings and antennae. Looking at that, the next one, who may not have smelt you, will do the same thing. So this would be, for example, an act of imitation. And a wave of this could actually spread in the colony, even though you have only started it at one corner. Sure.
So as a population or superorganism, this looks more frightening if 10 or 20 react.
It also is true that then they are actually more ready to fly out and sting you, attack you. They actually get ready. So my description, when the wasp is sitting with all the wings closed and the legs and the antennae, I call that sitting. And then when it raises its antennae, I call that sitting alert. And when it raises its wings, then it's an alarm reaction. And that is what they have to do before they take off to sting you. So they're actually getting ready. In addition to it being more frightening, they're also actually ready. And in some sense, there is honesty in that, because you are frightened because they are ready.
What he was defining as media is the extension of the body, or media as an extension of the central nervous system. One example would be mankind inventing the wheel, and the wheel is an extension of the leg.
Right.
The telephone is an extension of the ear.
Right.
Glasses or a photo camera is an extension of the vision. Did you observe once in your insects that they use this kind of extensions, or like I see ants bearing a stick?
Animals use that all the time. In fact, this is a very nice term for this. It's called extended phenotype. Now we of course have genes in our body, and by the action of those genes and interaction with the environment, the body is produced. So the body is called the phenotype, and the genes are called the genotype. So we have a genotype that interacts with the environment and produces a phenotype. So the shape of my nose, the color of my eyes, the size of my ear, this is all my phenotype. But that has come because of interaction of my genotype with the environment, right? Now, so this is our phenotype. And what Dawkins said was there is an extended phenotype. The nests that birds and insects build, the tools that animals make, the web that the spider makes. So he calls this the extended phenotype. And he showed how natural selection would act on the extended phenotype exactly as it would act on the real phenotype. Even a hole that the wasp digs in the ground is its extended phenotype, because the hole is not deep enough, or if it is too deep, it won't work. It has to be of the right depth.
Yeah, McLuhan is also talking, here's the example of a light bulb. The light bulb is creating a certain environment. For instance, if it's dark and I switch on the light bulb, then, because then I can make use of the room at night.
Right.
Yeah.
So technology is our extended phenotype. So when the spider sits in the middle, in the center of its web, and it is able to see, even if the insect there, some insect coming, it can see the vibration from here, and then it can run and catch that insect. That's an extended phenotype, which is not very different from our fishing rod. We have a fishing rod, and as soon as a fish catches it, we get a signal. Well, then I see no difference between that and the spider web. Both of these are extended phenotypes, or tools of some kind which we use to enhance the power of our senses. Certainly their nest, which is certainly an extended phenotype in which they rear their young ones, they lay their eggs inside that, and that itself is their extended phenotype, which they would not be able to do otherwise. There are some animals which just deposit their eggs in the environment, and they are not so successful as the social insects, in which they are able to build a nest. And the honeybees, for example, can very, very finely regulate the temperature of their nest. You can have temperature fluctuating outside from minus 40 degrees to plus 40 degrees, but here it will be 37 plus or minus 1 degree centigrade. And the wasps also do this to some extent. So if it gets warm, too warm, they will bring water and they will spread it on the nest, and then they will fan their wings and evaporate this water and cool down the nest. And if it gets too hot, they will go and drink honey, and they will metabolize it and produce heat and pump their abdomens and transmit heat to the nest.
So if they might use their nest as a media of extended phenotype, also to communicate with each other through that artificial.
Again, the nest is very convenient for vibration because it is made of very fine paper, and so vibration signals spread very quickly. so they use it as vibration. In our species, we have evidence that the queen applies a chemical substance to the nest, so that even when she is not there, the workers know that she is there, and they are able to apply this to the nest.
So there is no lack of queen.
Right.
So that they understand.
Yes. But it also works the other way around. So if she's really dead, then she doesn't apply for a long time, and then that smell goes away, and then they realize that we don't have a queen. So we've actually been able to take the queen away and just put the chemical, and they think that the queen is there. We can fool them in this fashion.
And that works out.
Yes.
Then they don't start.
They don't start fighting. Yes. At least for a while, we can show that this is there.
Mm.
So we do experiments where we look at how much they fight in the presence of the queen. Then we remove the queen, and the fighting goes up. Then we put back the queen, and the fighting goes down. In the next experiment, we see how much they fight with the queen. We remove the queen, the fighting goes up. Now we put only the chemical, and the fighting comes down.
And fighting is a preparation for finding a new queen.
Finding a queen is slightly more complicated than that. It is not random fighting. What happens in our species, we have evidence that the successor to the queen is sort of decided beforehand. But she becomes very aggressive when it is her turn to become, because she still doesn't have the chemical. But this aggression is one directional. Nobody challenges her because it's all been decided beforehand. But she announces now that she is the next queen by becoming very, very aggressive. And that aggression comes down if the original queen quickly returns. So if you take the queen away, she thinks now it's my turn. But within 24 hours, if the queen comes back, she realizes, oh, it was a mistake, and she just goes back to work.
And if she would still go on, behave aggressive, she would be killed by the queen?
Yes, so they would fight then. So now she avoids that fight. But if you allow her to be the successor for a little longer, then she actually begins to develop those chemicals. Now, if the queen comes back, they will fight. So we can actually show that early in the game, if the queen comes back, the successor goes back to work. But if the queen comes back too late, then she is challenged.
So this chemical certainly is a media as well.
Right,
Yeah,
exactly.
it's a tool to communicate and to make clear who is chief commander.
Yes, exactly.
And so that differs each.
Every individual could be different, and also individuals from one nest, another nest will be different. Within the nest, the queen and worker will be different. The male will be different. I'm sure it is even more complicated. Suppose I have been bringing some kind of food, then I smell differently from you because you have not been bringing that kind of food. So there's information about my species, about my gender, sex, about my hunger, about my health, about what I've been doing in the past. All of this could be contained in the smell. So in the honeybees, for example, workers who feed the queen and lick the queen and take care of the queen for some time, and then they come out, then they have smell from the queen. And another worker who hasn't been to the queen for a long time will be able to get from this worker information whether do we have a queen, how healthy is she, how old is she, all of that information. Similarly, this worker may have been out foraging on a eucalyptus tree, and this wasp, which has not gone out at all, knows that there is a eucalyptus tree with lots of flowers in the near to the nest. So that's how they exchange information through these chemicals, which is in some sense outside the body of the bees themselves. That's media.
And that is also, in a way, social media.
Yes, and like in the human case, this media can be misused by others. So there is a famous example of an ant species which produces a certain kind of chemical when there is danger. So the few individuals who sense the danger will produce this chemical. This is called an alarm pheromone, an alarm substance, which will then make everybody become very active, make sure everything is all right. So generally they stop doing everything else and they become very active. Now there is another ant species which raids this ant and steals their pupae. It goes there and steals the pupae and brings them to its own nest. And when these pupae become adults, they don't know they're in the wrong nest, they work. So these are called slave-making ants. So these are species which are slave-making ants. The queen only produces very few workers and then sends these workers to steal slaves from other colonies. Kidnap, bring them here, and then she then is able to invest most of her resources into producing future queens. The other species have spent a lot of their resources producing workers because the workers have to feed. So they will produce few future queens, these will produce many future queens. But how do you steal? So there is one very famous example. This ant, which is a slave maker, their workers go to that nest and release a substance very similar to the alarm substance. The only difference is that there is a double bond there, which makes it a very stable compound. So there is perpetual danger. There's so much danger, there's so much confusion, that in that confusion they can steal all the things. So here media is being misused by somebody else.
Called Ludwig Jäger in Köln, and he's talking about the epistemology of the disturbance. He says disturbances, or like we discussed at lunch, failures are very important for us.
Yes.
And he says regarding the use of media that if there is a disturbance of the media, then it's like in the figure ground principle that the ground is getting important and that the media is getting opaque. It's not transparent anymore. As long as the media works, we do not realize that there is media because it's just working.
Right.
Yeah. And in one Skype performance, for instance, we had that case that the Skype connection was disrupted and the two performers had no connection, and then they went on for 90 seconds independently, and after 90 seconds Skype connection was re-established and they found together in a very nice way. Yeah. Do you have an example in the communication of insects where this takes place as well? The media is not working anymore, yeah? So they have to improvise in a way. They cannot rely on the media anymore. And how do they react?
In many species, they have a series of backup systems. So if one doesn't work, they will quickly switch to the next one. And the best example of these backup systems is in the honeybee dance language. So when honeybee forager goes out and she finds food, she's able to come back and perform a dance and communicate to the bees at home about the location of the food. And she does this by actually looking at the sun's position. So she behaves as if she can measure the angle between the azimuth of the sun, the source of food, and the hive, and she seems to be able to measure this angle and use this angle while dancing. Now, if this is true, then honeybee should not be able to communicate when there is a cloud, right? And so you would think that your theory is disproved if the honeybees continue to dance and communicate when there is a cloud. And unfortunately, it doesn't work like that. If there's a cloud, they will still dance and communicate because they have a backup system. They will switch. If they cannot see the sun, they will sense the plane of polarization of light. See, when the light comes from the sun, it is not polarized, but when it hits dust particles in the Earth's environment, it gets polarized. And how much it gets polarized depends on where the sun is. Because wherever the sun is, it's not polarized. Away from the sun, it is more and more polarized because it has traveled more and more. So by looking at the pattern of polarization of light in the sky, you can now, with instruments, we can tell where the sun is, even though we can't see the sun. The bees have such an instrument and they can tell where the sun is. So if it's a cloudy day like this, no problem. They will still continue to dance, but they are able to locate the sun through this polarization. Now you would say, suppose the cloud is so thick that they cannot even see the plane of polarization. What would they do? Would they stop dancing? Now if they dance, your theory is disproved? No. What the bees do is, if it's completely overcast, they cannot even locate the sun through the plane of polarization. Then they will resort to their next backup system, and that is landmarks. every day on the first flight out, they learn the landmarks. Almost never use them, but they learn them every day. When this situation demands, they will be able to locate the sun through the landmark. They don't use the landmark. They say if the sun is behind that tree, it must be 4:30 in the afternoon. So that's how they will again pinpoint to the sun using landmarks. And in a famous experiment, it was shown that they have one more backup. Now, what do they do at the equator when the sun is exactly above your head? Then you can't use the sun. If you draw a perpendicular sun, it comes on you. It doesn't come to the horizon. So von Frisch wondered what would the bees do at 12 o'clock in the afternoon in the tropics. So he sent one of his students to study this, and the student found that at 12 o'clock the honeybees take a break. They stop for some time because they are not able to communicate in that way. So animals often have these backup systems. So when one fails, they switch to another.
They switch the channel in a way.
They switch the channel, and they have a number of channels in place to do this.
Last week I read an article about dung beetles, who's obviously seen
stars.
Milky Way.
Yes, we see the Milky Way.
Which is amazing.
Yes. But occasionally people have succeeded in forcing animals to actually improvise. That is, you put them in a situation. See, the honeybees in their evolution have encountered bright sunny days, they have encountered partially cloudy days, they have encountered very dark days, they have encountered the tropics, so they have built in all of this. But suppose you put an animal in a situation which has never encountered in its history, then then you can see how they improvise. So there's a famous study of, again, example with honeybees. There is a plant called alfalfa, which is a new world plant. Honeybees are old world. Honeybees evolved in Europe, in Asia, in Africa, but not in the Americas, not in Australia. Human beings transported bees to North America. But in North America, there is a plant called alfalfa, which grows very rapidly, which people use in the cultivate. Honeybees cannot forage on that because the flower is such that when the bee tries to enter, it snaps open and gives a kick to the bee, and the bee then falls far away. And it's such an unpleasant experience that the bees will never go back to that flower again. In America, you have bumblebees, and bumblebees are fat and stouty, and they forage on these. And honeybees will always avoid this. So somebody did an experiment and said, let us see what will happen if you force the bees to forage on this particular plant. So they grew a very large field of these and honeybees in the center of it. And they had no choice but to do this. And they found that bees then improvise, and they found that different bees have different strategies to deal with it. One strategy was that the bee will go to the flower and wait for a bumblebee to come and do this opening process, and then it will go inside and take. But other bees, because now it is complete improvisation, it's individual thing, other bees learned that you can bite the flower at the bottom and enter through the bottom and avoid being hit by this opening of the flower. So there are some examples where you can actually force the animals, put them in an environment which they have never encountered in their evolutionary past, and then see how they might improvise. And it looks like they can improvise.
What is your main question that you still want to find out in the observation of your wasps?
Well,
what would you be most curious on to find out?
There is a sort of specific small question, and then there's a big question. And the big question we will probably never be able to answer, or we will not know if we have answered it, because that's true with big questions, Is there God? You don't know whether you have answered it or not. So we have one such big question, and that is, why do they cooperate? Because many insects don't cooperate. Why do they cooperate and live in these social groups? So this is the big question. We think we have some part of the answer, but we will never have the full answer. And as I said, we may not even know if we have the full answer. But there is a more specific, narrow question, and I will know exactly when I have the answer, and I don't have the answer now. And that is in the species that I study. As soon as you physically remove the queen, there's one and only one individual who takes over, and she is not challenged by anybody. You take her out, one individual takes over. So there is a line of succession which seems to have been decided beforehand. But we cannot predict who this individual is, and that is one of our most frustrating in some ways, but also the most interesting challenge. It's a very interesting and complicated experiment. So we cannot predict, but the question is, do they know? And many people told us that you cannot really, this is not a scientific question. How do you know whether the wasps know anything? And we designed an experiment which convinced us that they know. What we did was we took a colony and we cut it in two parts. And we put a wire mesh screen in between. When you do that, and then we distribute the workers equally, half of them here, half of them here, randomly chosen. The queen here, queen can be only in one of the two halves. And we have shown before that in the half that does not have the queen, they are not able to sense the queen across the wire mesh because her chemical is not volatile. So they think they don't have a queen, and immediately they will have a new queen, a new successor. This we have shown beforehand. So what we did now was we said, imagine that there is a pre-designated heir to the queen. Everybody knows, except us, suppose. Then when we do this experiment, the way we do is we remove all the adults and we cut the nest with a knife. We put a wire mesh screen in a cage, and then we take each wasp, we toss a coin. Heads you go to left, tails you go right. We do this for each wasp. Then the queen, toss a coin, heads you go left, tails you go right. So suppose the queen has gone to the left and there's no queen on this side. And suppose there is a heir designate. There's a 50% chance that she is here. If she is here, she is the heir designate for the whole colony, so surely also for this side. Immediately she will become the next queen on this side. Now what we do is we leave all the workers where they are. We take the queen and move from left to right, and we take this new queen right to left. If she is the heir designate, she should be acceptable to these workers. No problem. She's accepted here, we put her back, she's accepted on both sides, as long as the queen is not there. But this can happen only in half the cases, because in the other half cases, by chance alone, the heir designate is in the same side as the queen. She can't do anything. Here is a half without the queen. So of these, the best individual or whoever is the heir in this alone will become like the queen here. Now when I move the queen from left to right, and this new queen from right to left, she comes in face to face with the real heir designate, who is the heir designate for the whole colony, and this one is not valid. So immediately she should lose, and she loses. But she doesn't have to be told you are not the queen. As soon as she sees this queen, she goes back to work. She doesn't challenge that individual, and that individual immediately becomes the next queen. So by bringing the real heir designate with the false one face to face, we are able to show that without conflict, they resolve this. So obviously everybody knows who the successor is to the queen, but we don't know. And the fact that something that the wasps know, we don't know, is I think something that keeps us going. It's something that I, over the years now, have begun to find very interesting.
Could you imagine how does it feel to be a wasp? I mean, you've been watched hours, months on wasp, most probably, with a lot of empathy. And
yes.
Because that is your method. You want to get into their system and their perception into their body.
Right.
How far can you reach?
Well, one thing is clear, that the wasp's mental world is simpler than ours. There are fewer variables. For example, I cannot imagine that they plan very much into the future, whereas we do, especially modern humans. I think we live in a very complex world. So they certainly live in a much simpler world. But I do not believe that their world is simpler in the sense of sophistication. It is simpler in the terms of number of variables, how much into the future you project, how much into the past you remember. In those terms, their world is simpler than ours. But I do not think it is simpler in terms of integrating things, in terms of taking different kinds of stimuli and putting them together. I think they live in almost as complex a world as we do. So temporally, I think they are simple. In terms of time, their world is reduced, but not in terms of number of signals. In fact, there are many situations where I think they are much more sophisticated than we are able to do. A bee or a wasp will fly out of its nest in random directions till it finds food. Having found food, it flies straight back home. How does it know?
In a line.
In a line. How does it know? People have done experiments to show that we'll always have to use this language. We'll say the bee behaves as if it does. We don't know that it does. Just like I said, the bee behaves as if it can measure the angle between the sun's azimuth and the food and the hive and remember this angle. We don't know that it measures, but it behaves as if it measures. Similarly, the bee behaves as if. So I think they live in a very rich, complex, sophisticated world. And in that sense, I would think that if I were a wasp, I would have to be as intellectual as I am as a human being and not any less.